We're going to take a look at a second example here. And this question says, a daredevil is attempting to jump his motorcycle over a line of buses parked end to end by driving up a 32-degree ramp at a speed of 40 meters per second. How many buses can he clear if the top of the takeoff ramp is at the same height as the bus tops and the buses are 20 meters long? So we have our ramp like this, with an angle here, theta equals 32 degrees. And then we have our buses, delta x equals 20 meters. And the question is, how many of these can we clear with this travel here? We know that a in the y direction equals g equals negative 9.8 meters per second squared. We know that delta y, the final change in height, will be 0 because it's when the daredevil comes back to their same height. So that's 0 meters. And from our diagram here of our initial velocity, v naught equals 40 meters per second. We know that v naught x equals v naught cosine theta, and we know that v naught y equals v naught sine theta. It's got lots of stuff. The question is, how far does this person travel? Well, if we knew, we want to find how far, so that's delta x. So if we knew the vx and we could multiply by the time, we could get our distance. We know vx because vx equals v naught x, because there is no change in velocity as they travel horizontally. There's no change in the horizontal. So the question is, what's our delta t? Well, we can find our delta t from our kinematics equations and flying through the air. This is just like you've done with horizontal projectiles, except we have an initial velocity. So we know that delta y equals v naught y delta t plus 1/2 g delta t squared. So if we rearrange this and use the quadratic formula, we're going to get that delta t equals negative v naught y plus or minus the square root of v naught y v naught y squared minus 4 times 1/2 g times delta y, all divided by 2 times 1/2 g. Now delta y conveniently is 0, so this term goes to 0. And we get that our delta t, just like in the last example problem, will end up being negative v naught y plus or minus v naught y over g, which will equal negative 2 v naught y. Because if I put in the plus, we get 0, and so that's going to be the time when the daredevil leaves the ramp, which isn't useful. But if I plug in negative v naught y, that will be the time after they've traveled and at the other side. So we get our delta t equals negative 2 v naught y g. So then we come back, delta x equals vx, which is going to be v naught cosine of theta, times delta t, which is negative 2 v naught sine theta, all divided by g. So that will give us negative 2 v naught squared sine theta cosine theta divided by g. I'm going to check our units real quick and then leave the actual plugging in to you. But our units, v naught squared is going to be meters squared per second squared. And then g, 1 over g, will be 1 over meters per second squared. And so then we can flip that when we multiply it. And we get meters squared per second squared times seconds squared per meters. And that will cancel everything except for 1 meters on top, which is good because we were looking at delta x. Then we're just going to, for our final answer, number of buses equals delta x divided by 20, and then round down. Because if we want to figure out how many buses we've actually cleared, we can't, if it's 15 and a half, well, then we can't clear that last bus, so we round down to get just the 15. If you have any questions, let me know, but otherwise this is kind of working through an example for you.